Hello, welcome to class 6 of the ArchiCad 23 online course. In this class we are starting the section 2 and we're gonna indeed start the house project with the terrain modeling. So the first thing, open the template file, template AGA. If you aren't working on international version, open the template in PLA. When you open a template, it is an untitled file, as you see here. So click File, Save. The PLN extension is displayed. I will save, naming it as Class 6. And then this PLN file is saved, keeping the template file unchanged. The first thing to start a project is to set location information. Go to Options, Project Preferences, Project Location. We have seen these options in a previous class, so this time I will change only the project name. Clicking here, Edit, Project name, I will type Orlando House. Okay. Here in the navigator at the right side, you see that the project name is changed. Now I will create the stories in my project. So here in this first icon, project map, click with mouse right button over stories, story settings. So here in ground floor, it will be the level plus 170. So here on elevation 170, it's in centimeter. Above this story is the first floor, that is 3 and 23 above. So here I put the difference from one story to another. So here on first floor, I'll type first floor plus 4 and 93. After that, I will insert the roof level 3 meters and 10 above. So here I put 3 and 10, insert above, here type roof, and it is the level 8.03, and after that select the ground floor. Under the ground floor I will insert the underground level, so here I will click Insert Below. I'll type Underground. It's gonna be minus 1 and 19. Minus 1 and 19. Below all these stories, I'll put the terrain. So I click Insert Below, Terrain, and there is no exact level where the terrain should be, so I can freely choose. I'll put -3, so here -300, and so it's done. Here on Navigator, you see the created stories. To activate the story, do a double click and it gets as bold text. Click on Terrain and we're gonna insert a topographic survey in DWG. We generally receives it in DWG. Go to File, the external content, and here we could make it in two different ways. One is attaching XREF, but since ArchiCAD version 22, it has shown many problems, so I prefer to use the external drawing method, and that's what we're gonna do. Click on Place External Drawing. In the folder of DWG references, choose the file Orlando House Topography, open. I work in centimeters, but as I don't have this option here, I'll put custom millimeters 10 by 1, because multiplying millimeters by 10, we get centimeters. Place, I'll click here. The program is searching a font. I will skip all. This drawing comes as a block. I will place the side corner into ArchiCAD's origin point. So Ctrl D to drag. I'll click here at the corner. And after that here, in this X, that is the origin, to be used as reference. We need to explode the drawing, and it's very simple. Just clicking with mouse right button on empty area. You could see this option, explode into current view. I click here, OK. And you can select only the background and erase. I'll press delete, and then I'll keep just the lines of this object. But some students have related problems to explode the drawing, and now I will explain why it happens on ArchiCAD 23 and how to solve it. Ctrl Z to undo. So I come back with my drawing in a block. If you have this problem, go to Document, Renovation, Renovation Filter Options. Inside here, if your ArchiCAD is marking the option Existing Plan, you need to change it for Show All Elements. Or, here in Existing Plan, you'd have to put New Elements here as Show. But I'll keep this as Hide Elements, and I'll choose Show All Elements. And the reason is that the drawing comes as new element and it disturbs when you try to explode. So click with mouse right button, explode into current view, click OK, and it's done. The drawing is exploded. I select the drawing and erase the background, pressing delete. I will turn off suspend groups, so keep it unmarked, to select many objects at the same time, as I do in here. Select the drawing and go into settings dialog. Here, you can see that the renovation status of this element is new. So this is the problem. I'll change to existing to avoid other problems. I'll keep this as existing element. I'll change line paints to a red color to highlight. 113. And also select the texts and change to red. Then my topographic drawing is ready. It is just a 2D drawing brought from AutoCAD. So now I'm going to use the Mesh tool to model the terrain. Go into Mesh tool. I can also do a double click to enter on settings dialog. So here first I can choose how much soil volume we're gonna have beneath the base level. I'll keep 1 meter. Next one is the level in relation to home story. I'll keep 0. The home story is terrain, which is -3 to project 0. Here we have the option to show only the surface with projections, or surface and earth volume. I'll keep it. Building material, I'll choose soil. 2D representation are already correct according our template. So here in cover fields, I will keep this green solid. In model, I'll keep the upper surface with grass green. And I could turn on other surface with earth brown, but it's not necessary because it's using soil material here in building materials. In layers, I'll keep Arc3 existing site. Okay. Here on geometry method, I'll choose rectangular. Click on the corner. And finalize clicking on opposite corner. Pay attention to precision. The mouse is a white pencil and it becomes a black pencil when the node point is reached. I do a click and here you have the mesh. It is above the curves. So select the mesh. And here in this bar, I have the option send to back. Looking on 3D window, you see that the terrain is plain with 1 meter of soil. So selecting it and going to settings dialog, we could see this earth volume. If I put 2 meters, you see the earth volume increasing. I'll keep 1 meter. Well, to understand the project, this curve on the entrance of my terrain is H30, and it's going to be the 0 level in my project. Thus, H31 is 1 meter above. The terrain comes back to 0 level, and then H29 is -1, and H28 is -2 meters. So this is my project, and I will select the mesh I have modeled, and clicking on Mesh 2, I'll place the mouse over this first curve, H30, and pressing space bar, the magic wand appears. Do a click, and this window, new mesh point, I'll keep these options, press OK, and the level curve is created. I will make it for all curves, pressing space bar and clicking. Going to 3D, you can see the curves, but they are all plane. So now let's elevate the points. Select the mesh, click on a point in the middle of the curve. This floating palette appears. Click in Elevate Mesh Point. Inside this box, change the reference to project 0. this curve is on 0 level. Mark apply to all because we want this level applied to all points in this curve. Okay. And you see the edges being created. I'll do the same steps to next levels. So here, I click in the point. It is 100. Next is 0. Here I have the -1 and -2. Pay attention not to select the 2D drawing. Here is the 2D drawing and here is the mesh. So you need to select the mesh, click in these points. Going to 3D, you see the curves in different levels. However, the corner points are not on correct levels yet. In floor plan, the topographical survey indicates these points. So I click here. I'll change again to project 0. And here we have 830.22, so it's 22 centimeters. And this time I won't mark apply to all because only this corner point will be elevated. Next point is -7. Here we are 7 centimeters below -2 meters. So it's -207. And the last point is -230. In 3D, you can see that everything is right. Just before we continue the plane, I'm going to show some modeling options. Selecting the mesh and clicking on the mesh edge, the floating palette allows you to insert a new point. So I can insert new node. I can curve the edge. Edit segment using tangent. Offset edge. I can put a value. Offset all edges. Add to polygon. So I could choose here a geometry method. It could be a polygonal form to add in the mesh, or rectangular, for example. Subtract from polygon. It does the same, but subtracting. So we have these options, and clicking in the node, we have other options like move node, fillet and chamfer. So I could put a fillet value here, radius. So for example, 3 meters of radius, or chamfer. So we have all these options. Now I will fix these sharp edges in the middle of the mesh. First, in floor plan, I'll put the 2D drawing in the topographic layer to be closed. So here on layer, I'll put it in the topographic DWG topography. I'll select other polylines that I need to change to this layer that is closed. Here I have the texts and some other points here. Okay, so select the terrain, floor plan section. In outlines, we have read selection, and I'll choose show user defined reads. So now 2D representation is right. In 3D, we still see these sharp reads. Select the mesh, enter on settings dialog, and here in model, I'll put all reads smooth. Okay. So here in 3D, the terrain is correct now. With the terrain finished, we're gonna do now the sidewalks and street. I will turn on the DWG topographic layer, Ctrl L to enter on layer settings. And here I will turn on this layer. We can see the levels on sidewalk, the bottom level of gutter and the top level. Clicking on Mesh Tool, I'll enter on Settings dialog. I'll choose Concrete Material. So here I'll put Concrete. Here in Floor Plan and Section, in 2D representation, I have in Cover Fill this green solid, and I'll put a white pen here, 126. In Model, I will turn on all surfaces. I will turn on Padlock as well, and change to Concrete 02. Okay, using the rectangular method, I model the sidewalk. Now I will create new points in the sidewalk. Send to back. Select the mesh and click on the edge to insert new point here on this level dimensions. So first I click in the edge, select insert new point. Click here. I'll insert other point here and other here. And now clicking on each point, I can elevate the levels. Just before it, I will put some points here in the corner, the middle of the curve, and in this corner. Now I will elevate the points in the curve. I'll put here elevate mesh point, 0. Here is -7. -22. And here, near the gutter, we have the -13, 2, and 16. The edges I can elevate in 3D. So here I have these edge points that I can click. I can choose here elevate mesh point and use as reference this point here. That is the nearest point. Here on the other side, I'll do the same. Using as reference the nearest point, I will elevate in 3D. I will copy the sidewalk to the other side, select, Ctrl-Shift-D to drag a copy. For the street, I'll put new settings on Mesh 2. So enter here on Settings dialog. In Cover Fields, I'll change to light gray 160. In Model, I will select Pavement Asphalt Light, change the layer to Arc 4 Pavement. I forgot to do it for sidewalk. Okay, using rectangular method, I will model the street. Here I will send to back. And once more I will insert new points in the mesh. Clicking here, I will insert these points in the same places that I did for sidewalk. Go into 3D. You can see it, and I can elevate these mesh points using the sidewalk as a reference here in 3D. So clicking in these points, using elevate mesh point, I can click on each one and elevate these points. Now, it needs to be 20 centimeters below the sidewalks. I select the mesh, use the shortcut Ctrl 9, type -20, okay. Therefore, the side context is ready. To finish, I will turn off the topographic layer and apply the ridges corrections as well. So Ctrl L, I will close DWG topography. In here, selecting these meshes, floor plan and section, ridge selection, show user defined ridges, and then 3D, I will select them. Settings dialog, all ridges smooth. Okay, this was the class about terrain modeling. I hope you have enjoyed it. Until next time, bye bye. Hello, welcome to class 7 of the ArchiCad 23 online course. In this class, we're gonna see how works the logics of the ArchiCad's constructive tools, building materials, fields, and surfaces. So before continuing the house project, I will teach about it because it's very important to understand the next steps. In floor plan, I will model a basic wall. So here I will choose single wall. And entering on its settings dialog, you can see the building material that is masonry block. It is the wall core, the material in the middle of the wall. And in model we have surfaces that can be turned on. And these are finished materials to be seen in 3D window. So here I will turn on the padlock to change 3 materials at the same time. I put a white paint. And you can see in 3D the surface applied in this wall. Going to settings dialog, if I turn off one of the sides of the wall, you can see in one of the sides the original material used in building materials. So when I don't have override surfaces, the element shows the building material. And I could change the override surfaces to show another options. Here, for example, I could put a stone. Then see this surface material. And changing the building material here, concrete for example, you can see how works the logics of building materials and surfaces. Going to floor plan, you can see here the configuration in concrete. I will come back to masonry block. So here in floor plan, the fill corresponds to the building material you are using. And you can manage building materials going to options, element attributes, building materials. I can order materials by name or intersection priority. Clicking here. I will select masonry block filler. This is my material. Here we can choose the fill type and the pans used in this fill. The first pan is for lines, in this case, and the second is the background. So changing the background for a white color, for example, you can see it in the symbol here. And all masonry blocks in my project will get this configuration. Pressing OK, you can see it. So I could have many walls using this masonry block and the same configuration for them. Coming back to building materials, I will return it to light gray, and you can see these changes. In building materials, you could also change the representation in 3D. So going there to building materials, I have here this representation in 3D. The intersection priority is when the composite materials are intersecting one each other. We're gonna see it later. Below, in classification and properties, we have here some options, including physical properties like thermal conductivity, density, heat capacity, embodied energy, and embodied carbon. This data are used especially if you work with EcoDesigner for energy efficiency analysis. And clicking on Open Catalog, here you have this option, Open Catalog. You can access this material catalog with many other materials, and they come with specific physical properties. So you can insert new materials with correct information. So I have many materials, for example, metals, aluminum, brass, bronze, copper, cast iron, lead, stainless steel. So I could close it and go into floor plan. Those definitions of building materials are applied in all the project in general, but I can also add the fields for some individual elements or specific elements. Selecting the wall in floor plan section. In cut surfaces, we have the option override cut fill pans. And I can override the foreground, background, or both. Selecting background, for example, it could be white. Only this wall that I changed the background, it's getting this configuration. So going to both, for example, I could make a solid fill. So choosing the same colors, the masonry block, it's using these colors, and it keep being a masonry block wall, but with another representation. We also have composite elements. So changing it for a composite wall, here I can see some options in settings dialog. So choosing a composite wall. We can see the finish layers in floor plan and go into 3D. We can also see these composite layers since override surfaces be turned off. So this surface in the middle needs to be turned off to see the finished layers in 3D. Turning on the middle surface, you see the override and composite doesn't appear on 3D. So I'll keep it turned off. And beyond these constructive fields used in building materials, we have the possibility to make a 2D fill in document. We have the fill tool. So entering on settings dialog, you can choose the contour line. And you can turn on and off the contour line. And the fill type separated in categories here, like cut fill, cover fill. So choosing a cover fill, for example, I'll put a grid. And I choose the foreground pen and the background pen. Choosing the geometry method, I can draw this fill. That will be just a 2D element, not displayed in 3D. Okay, this was the class about building materials, fills, and surfaces. In the next class, hello, welcome to class 8 of the ArchiCad 23 online course. In this class, we learn to work with DWG references and we model underground level using slab, wall, column, and beam tools. So to begin, we're gonna insert some DWG references to model the house. But here, an important explanation concerning DWG references needs to be done. I'm gonna use these DWG drawings made on AutoCAD. So here I have basic drawings with walls, axes. And you could ask me, do I really need to draw on AutoCAD first to work on ArchiCAD? No, you don't. You can start modeling direct on ArchiCAD, and including you can use line tool to draw a sketch. So here in document, you could use the line tool in worksheets, and it's perfectly possible to create your project entirely on ArchiCAD, not using AutoCAD in any moment. But in some projects, making a basic drawing in AutoCAD can really help you to do a faster modeling on ArchiCAD. And in this course, the reference can help the students to model a project never seen before. So let's start. To put a DWG drawing as reference, I will create worksheets. Go into Project Map. We have Worksheets here. Click with mouse right button, New Independent Worksheet. Reference ID is a logical sequence to organize the elements. I will keep. And here I will type underground. Create. And you see here this created sheet. It is an independent 2D sheet. Go to File, External Content, Attach XREF. I will just show this method quickly, but I won't use it. I will keep scale 1 and 1. I'll click Browse and select Underground here in DWG References or Land or House. I have this file, Underground Floor. I will open, retry because my file is open. I need to close it. So here I will close this file, this AutoCAD file. Here I'll keep, and coming back to ArchiCAD, I will select again, Underground Floor, open. I will skip all. Here I'll click to insert the origin point. OK. You can use fitting window to fit the drawing in your screen. And here I will check the scale using Measure Tool. I have this ruler. I am working centimeters, so here I need to have 2000. That is 20 meters. And here 50 meters, 5000 centimeters. And when I place a drawing as XREF, it remains like a direct link to AutoCAD. So making some changes on AutoCAD file, you can see the update inside here. In the AutoCAD file, I could make a rectangle, for example, so I will open again on the ground floor. And here I could make, I'll do a command here, a rectangle, just to show you an example. I will save. And after saving, I need to close this file. And here on ArchiCAD, File, External Content, XREF Manager, select the drawing, reload. I'll click OK, and here you see the update in my drawing. Another manage option in XREF is about layers. Control L to layer settings. Below all ArchiCAD layers, we have the layers that comes from AutoCAD. And here we can open or close some layers to manage the project. Okay. But I have to say that XREF method has presented many problems since ArchiCAD 22. Sometimes the draw doesn't attach, sometimes it disappears. So I prefer to use the external drawing method. Considering it, I will detach the drawing. File, External Content, XREF Manager. I will select and detach. Remove XREF attributes. OK. And now I will reinsert my drawing with another method. Go to File, External Content, Place External Drawing. I will select again Underground Floor, my DWG file, open. Drawing unit, I will keep custom millimeters 10 by 1. Place. I will insert in the origin point. I'll check the scale with Measure Tool. So here I have 20 meters by 50 meters. In this case, the drawing comes as a block, and I don't have the option of managing layers separately. The drawing belongs to one of my ArchiCAD's layers. Here, Arc5 2D drawings. I will repeat the same steps to insert other drawings, so let's accelerate the video to see it. Going on our project, we're gonna show these drawings as reference. So in my navigator, double click on Underground, So underground floor is active now. Click with mouse right button in worksheets underground, mouse right button show as trace reference. The drawing is displayed. Clicking in this icon, trace, you can turn on and off the reference. And here in this black arrow, we can see some options. Click tracing reference. And this box, I can keep here to manage references. First, the button to turn on and off. Beside, list to select the drawing to be shown. It could also be above or below current story. Switch reference is to alternate the views between worksheet and story. Here I can drag reference, rotate, reset, update. I can change the reference color, so it could be blue, red, orange. I'll keep it purple. And here I can control opacity. Active, I can set my drawings color in stories. For instance, modeling here, I will model a slab and a wall. These elements are my real constructive elements. And here I could change, for example, for red. And changing active color, I could make this contrast between them, or simply keep the original colors. So here I keep original for constructive elements and purple for references. Below, the option of temporarily displace my reference. So I could drag using the mouse. And second is reference on top. I will model again to see here some difference. So here the reference on top. I like to work in this way, so I just manage opacity and keep reference on top. Here we can show or hide like a slide sheet. So dragging from top or sides or bottom, you can manage it. And here the option of not showing fills. So you see the difference in the wall, not showing the background fills. And now looking on terrain, I click here in this story, and you can see that I have considered this corner as an origin point. So now I will place my references in this point. Go into underground floor. You realize that you may not drag a reference using the command Ctrl D. You need to click on this button, drag reference. And now click on this button here in the left corner and place on ArchiCad's origin point. So here I have my reference. I will erase these elements. So now, starting on underground floor, I choose the slab tool. Settings dialog. Slab thickness 12 centimeters. Level on home story is 0. And it's considering the slab top. Here in reference plane, I can choose it. So this 0 level is for the slab top. Building material is going to be reinforced concrete, structural. In floor plan and section, I'll keep the settings from my template. In model, I will turn on 3 surfaces and turn on also the padlock to change 3 materials at the same time. The concrete I want to use is not here yet. For a while, I choose concrete 02. And layer, I'll keep Arc4 structure. Okay. And using rectangular method, I will model the slab. First click here. I don't have a precision point here, so what I'm gonna do is place the mouse in this point. Snap guide appears, and then I have the intersection point. I click and finalize the slab. I can see in 3D. It is not being displayed because it's on underground level below terrain surface. So pressing Ctrl L, I will temporarily close the existing terrain. Site existing, I will close this layer. Okay. But as I said, I want to use a different surface material. So go to Options, Element Attributes, Surfaces. Clicking New, you have New from Catalog. In Linked Libraries, ArchiCad Library 23, you access this folder with various materials. I will go to Concrete. And here I have many types of concrete. I will choose Concrete Light. OK. OK again. Selecting slab. The surface material is displayed into the list now. Concrete Light. OK. And I will do the same for sidewalks made with Mesh 2. So here I will come back with existing because I need to change the layers from sidewalks. I'll put it on Arc4 pavement. And again, I will close site existing. I will select these two meshes, adding selection with Shift. And coming back here, I will put Concrete Light. Now, going to floor plan, I'm going to do the retaining walls. Select Wall tool. In Settings dialog, I'll link wall height to ground floor. Considering the difference from wall top to the upper floor at 0, we have 289 centimeters. Wall thickness is going to be 30 centimeters. Floor plan and section, I'll keep the template settings. In model, with all surfaces turned on, I will choose Concrete Light. In layers, even being a wall, I'll put this element on Arc4 structure because it is a structural element. OK. I model the wall until this column. And after until the circle, that is the bottom of the pool. And here I'll make a sequence of walls, so I'll change to chained walls. Starting here, I click on each point. And finalize here with a double click. Going back to slab, I will select the slab and create points to do this curvature. Selecting slab, so I will click on the edge. In the floating palette, we have insert new point, new node, and I'll click here and here. Click on the edge again. I'll select Curve Edge. And it's done. I'm gonna do curved walls. And wall settings remains as the same options chosen on last wall modeling. But to be sure that settings are the same, I can copy parameters using the eyedropper. Clicking here in eyedropper, I select the wall from which I want to copy settings. Click, and then I can draw the wall clicking on starting point. And at the end, here I will change to a simple wall, basic wall. I will select this element. In settings dialog, I change to 20 centimeters width, only in this wall. And clicking on the edge, I choose the option curvy edge. And so I can do this curvature. You see that walls are not connected because reference lines are not connected. So clicking in the node, I'll select this wall. You can see this blue line that is the reference line. The command is stretch. So here, with the reference lines connected, the elements are totally connected. I do the same here. But here you can see that clicking in the wall doesn't appear the option of stretch. So it is happening because this is a chained wall. This is a linked element. So I need to suspend group here, suspend groups. I'll press Ask and select. Now I can select only this wall individually. And clicking here, I have the option of stretch. Now I can extract and connect the walls. And after that I may return to group, turning off suspend groups. And now it is a chained wall again. Sometimes you can turn off the reference to see only your real project. And also in 3D. Well, I like to use in my preliminary design solid fills in cut elements. I will select the walls, holding Shift. I can add selection and go to floor plan and section in cut surfaces. I will override cut fill pans, both pans with 114. So my structure will have solid black fills. I will do the same for the slab. It's not being cut now, but when I create sections will be select slab, floor plan and section, override cut fill pans, both 114. This curved wall, in fact, is going to be a full circle. Click in the node. We have this option angular stretch. And you see that it's not accepting to complete the circle. So what I'm going to do is copy parameters with eyedropper. I use eyedropper to copy, erase. And then I will create the wall again using circular geometry. Passing the mouse over the circle, a center point appears. Clicking on it, circle add, double click and finalize the form. To make columns, enter on column 2. Here on ArchiCad 23 we have some news about this tool. Now it's possible to do variable sections, but we're gonna see later. Starting in the column menu, I will define dimensions. I will turn off padlock, 20 by 100 centimeters. Column height, I will link to the upper floor, ground floor. Keeping offset 0 column height is 2 meters 89. Here we have the option of slanting the column, possibility to integrate finishes of composite walls. Here we have the reference axis of core, that is the insertion point 2. I'll keep in the center. And layer structure. Going to segment, we have profile options. And in model, I will turn on surfaces and I will choose concrete light. In floor plan and section, 2D representation, I could use a symbol. Here we have the symbol type. So I should represent the axis in my structure. And other options, I'll keep plane. Classification and properties, the same information for all tools. I'll click OK. I will insert the columns using the reference. So here I put this first column. Ctrl-Shift-D, I will drag a copy to do the other columns. Here, I need to rotate the object, Ctrl-E. I'll copy again. And now I'll put solid fills. I can easily select the columns, adding selection with Shift, but I'm gonna show you another method to select. Marking column tool. You can press Ctrl-A, and all columns in the floor will be selected. Go to floor plan and section. Override cut fill pans. Override both 114. So here I have the structure in solid fills. I can check in 3D. It's lacking just the column beside retaining wall. In floor plan, I will copy parameters using the eyedropper. And I'll change just dimensions. I'll put 6 by 6. And this column is bigger because we have transition beams here to support pillars from the upper floor. Now we're going to do beams. Go to Beam Tool. On Settings dialog, we have dimensions. In these transition beams, a heavier profile is necessary. So here I'll put 50 centimeters height, 60 width. Here we have the beam top level. I'll put 2 and 89. Here we have the slanting options, curve, reference axis. In segment, we have profile options. Holder could make holes to pass pipes and ducts. Floor plan section includes projection mode. We have here some symbolic options, classification and properties, and layer, I'll keep structure. I'll just come back to segment and I'll change the surfaces. I will turn on all surfaces. And I'll put concrete light on all faces. Okay, I'll model the beam using this axis as reference. For the next beam, I'll change the width to 40 centimeters. I'm gonna use this column axis as reference. Here I need to connect the beams at the center. And here I could use the commands of stretch beam. I'll copy parameters and I'll just change to 20 centimeters to do the next. Here I'll do Ctrl-Shift-D to drag a copy. I can adjust using stretch. And I keep doing this modeling. Here I could make another beam. And to finalize here, we have these two beams. I'll select them, Ctrl-Shift-D. And now I can check on 3D. So here we have the structure of the underground floor. So this was the class 8. Hope you have enjoyed. Hello, welcome to class 9 of the ArchiCad 23 online course. We're gonna continue Orlando House's structure. To start this class, open the file Orlando House Class 9 Start. In this file, you have a part of the structure already done. I will turn off terrain layer, Ctrl L. I will close site existing. Then you can see I already did the slabs and columns of the ground floor, first floor, and roof. And I did it because it would be repetitive commands that I taught in the last class. So now we're gonna learn different commands. This house has a structure composed of pre-stressed concrete. And this is the reason because I have a 30 centimeters slab without beams. That allows big gaps between columns, and still we're gonna do steel and concrete columns to complete the structure. But for now, let's start making a ramp to access garage. Go into underground floor. I will put as reference underground in DWG. And here we have some ways of modeling this ramp. One of them is going to Object Tool and using a ramp object from ArchiCad library. But this object doesn't allow us to do this width variation that we need. Another important thing to know is that slab tool doesn't have the option of slanting. So you couldn't create a slanted slab to do a ramp. The best tool to use in this situation is Roof Tool. So let's go into Settings dialog. In this level, I will put -12 because it's the bottom level, the reference I have to use. I'll keep basic structure and 12 centimeters thickness. Building material, I choose reinforced concrete. Single plane. Here I have the slanting that can be defined in percentage or degrees. And I'll put 15%. I'm gonna set a vertical edge. In floor plan and section, I change just cover fills. I choose foreground and cover fill pans 126 white. In model, I change 3 surfaces to concrete light. Layer arc for structure. Okay. To model a roof element, the first thing to do is a line that is a base reference. It will be the bottom edge of my ramp. I draw the line. An eye appears. and I need to click in one of the line sides to indicate roof ascendancy. I click below the line, a pencil appears, and now I can draw the geometry. I choose polygonal geometry and draw the ramp. Cut fill are displayed here because the floor plan cut plane is cutting this element. You can check on 3D. You can verify the levels. In the ramp top, you see these level differences because the sidewalk has a slope. So now I'm going to do a confirmation adjusting the ramp. Go to floor plan. I will draw a line using line 2. I use the single line. Drag, Ctrl D, 1 meter. Now I have a reference to split this element. Select the ramp. Click on split, this X icon. Draw a line, do a final click, and now I need to click in one of the sides to conclude division. So now it is divide, erase the line. In 3D, you see the element divided, and this one I will turn to morph. Click with mouse right button, convert selection to morph. Click OK. Selecting this element to see the settings dialog showing it as a morph. So now we're gonna zoom in, click on node. In the floating palette, use the option move node and elevate until intersection point. To keep the thickness, I can elevate the bottom node. I don't have precision, but at least approximately. And do the same at the other side. Here in the middle, we have this sharp ridge, and what you can do is go into Model tab inside Settings dialog. I will select this element. Inside this dialog, Model tab, change Edge to Hidden. And then we have a smoother surface. Well, to understand exactly what you're going to do in this house structure, I will show some images. The final rendering. So here at the garage's entrance we have these sloped retaining walls, the stairs with recessed risers, this pointed concrete structure, and some slanted pillars. See in other images, you see these slanted columns. And now I have a better notion about the project. Let's proceed. Going to underground floor, you see this cut element. I'll change to the representation. Select floor plan and section. In floor plan display, I'll change to outlines only. Now you see the correct representation. I'm gonna use the eyedropper to copy parameters from the retaining wall here from swimming pool, 20 centimeters thickness. Eyedropper, I click here, and I will model this wall here, adjusting the reference side. So here I choose a single single wall using this reference side. Here I use the strat just to connect the lines. And the other side, here the retaining wall. I will invert the reference line. And here I need to correct this element. I'll put here some kind of adjusting element. So here I did a small wall to do this connection. You can check on 3D. And here we have these retaining walls. I need to do the inclination. So I need to model the stair here and go into ground floor. I'll put ground floor DWG reference. If you don't see it in the list, you can use the mouse right button over the drawing here in worksheets, mouse right button, and show as trace reference. So it appears here in the list. I can use the eyedropper again to copy parameters from the slab. I'll change just cover fields, putting white paint, 126, and using polygonal geometry. I click here to start. I do the polygon. And here I need the snap guide to find alignment. I place the mouse there. The alignment appears. And so I can conclude my polygon. Here in the middle, I have another polygon. And the other side of the stair. Backspace. If you do a wrong click, you can use backspace to return the command. Snap guide to find the intersection point and finalize the polygon. You can see it on 3D. And now I will elevate this first one, select, I'll press Ctrl 9, elevate, I will elevate 80 centimeters, OK, and I'll change to 80 centimeters thickness as well. Here on these slabs, Ctrl 9 again, I will elevate 30 centimeters and change to 30 centimeters thickness. Now I will model the stair. Select this wall, click on Node, and choose Strat Height. I will adjust until here. Go to Floor Plan, eyedropper to cup slab. I change thickness to 10 centimeters and level 0. I model the stair tread. Go into 3D. This element is on level 0. Riser will have 18.8 centimeters. Select the slab, Ctrl 9, minus 18.8 centimeters. OK. And now in floor plan, I will select this element, To multiply, Ctrl U. I choose drag, increment, 7 copies, vertical displacement minus 18.8. I'll click OK, starting this point and finish here to have a reference. I just need to adjust these edges. So I press ESC to retire selection and clicking here at the edge, in the floating palette, I'll choose Offset Add and do the same. I'll do the same thing for all threads. You can use as a reference this black pencil or perpendicular sign. In 3D, you see the stair, and as it is an untypical stair type, I'm doing with slab tool, but you're gonna learn about stair tool creating stairs inside the house later. Now we need to do a surpass one thread over another, clicking on the edges on floor plan. I will do a 20 centimeters offset edge for each slab here. So here 20 centimeters, 20, and so on. Just on the last, I won't do because of the retaining wall. So in 3D, you see the difference, but in floor plan, we need to adjust the representation, turning off the reference. You see that the order of elements are incorrect. Starting here, on second thread, I will bring to front, one by one, bringing to front, to create risers, the most easy is use slab tool too. I'll drag a copy of the first slab, Ctrl Shift D, drag the copy to origin place, and use offset of 100 centimeters by one side and 10 centimeters on the other side. Placing the mouse over the elements and pressing Tab key, you can alternate among selections, and clicking, you can select the preview in blue. Going to 3D, you can drag the slab on vertical to do the riser. I'll press Ctrl D to drag, and clicking on node, stretch height, and adjust the height. I'll copy this element for the second thread, Ctrl Shift D, I use this point as reference, click here to add, offset add. Here on 3D, Ctrl D on vertical. So here I will adjust stretch height, and this height can be copied for all another threads. Going to floor plan, I will select this element, Ctrl U to multiply, one more time drag, increment, 7 copies, 18.8 centimeters, OK. I use the starting point as reference, click here, And all the work is just offset add for all these elements. Offset add. I can press tab 2, the tab key, selecting these elements and adjusting offset. To do inclination on these elements, we need to convert them into morph. Select, mouse right button, convert selection to morph. OK. Click on the bottom add, offset add, and go down until this face. Click on upper add. It doesn't have a precision. I'll type 215. On the other side, I do the same. Convert selection to morph. Click on bottom add. Offset add. And the upper add. I may use the reference from the other side. Now we're going to cut this wall using the solid element operations. So I will press ESC to get out from all selection. Click on design, solid element operations. This window is open. I select the morph, click in get operator elements, select the wall, click in get target elements, and here we're gonna choose the operation subtraction with upward extrusion because we want to cut everything above the sloped morph. Click execute. You see a little piece of this wall not being cut, so I will decrease wall thickness to 18 centimeters. You can see here on the underground floor. This wall I change to 18 centimeters thickness. So now in 3D, you see the correct representation. On the other side, I can use the same strategy. I'll select the morph in ground floor. I can activate the ground floor DWG to have a reference to mirror a copy, Ctrl-Shift-M. I'm going to use this line. So here we have this element, and on 3D, I do the same solid element operations. So morph is the operator element, wall target element. I click execute, and here too I need to do little adjustments. So here in this wall, on the ground floor, I'll select the two walls, clicking on node. I can do a video adjustment. This position. So on 3D, you can see that now the elements are being cut correctly, but here still there is a piece. So again, this wall I put 18 centimeters thickness. And now you can see it is correct. I select this wall, click on node, straight height. And now we have this entrance. And here I need to adjust this wall because the reference line was changed. Here I need to reconnect the element using strat. On 3D you see it. So now it's alright. Coming back to the other side, I will split this wall here on floor plan, ground floor, better in the underground floor. I select the split command, draw the line to divide. On 3D I will convert to morph. And here click offset add. Here, depending of the angle you choose this edge, it doesn't get the weight that you want to do. So here I'll try to do another angle on my 3D window, and now you can do this morph element. Here I could do a solid element operations. I put this as operator, target, subtraction with upward extrusion, execute, and then we have this now. Here on 3D, you see these lines between elements. It can be a problem to solve on 2D drawings as sections and elevations, but no problem to rendering because they are using the same surface materials and are aligned in the same plane. Now I'm going to do this concrete railing. You can see it on images. So here we have this concrete element. And in 3D, I can do a copy. I do here an orbit command. I will select it, Ctrl-Shift-D. On Z-axis, I can do a copy. And this slab here, I'll put a 1 meter level and 65 centimeters thickness. I'll do another copy, Ctrl-Shift-D. But this one with 5 centimeters thickness. Going to ground floor. I'll keep the reference, DWG reference ground floor. I will do an adjustment on the form, clicking on node, move node, and here you can check on 3D window if the correct element was changed. I'll keep just the bottom element in the same place. So clicking on node here, I'll choose offset all edges, and going inside I'll click 5, enter, and so we have 5 centimeter offset. Now select the element, mouse right button, convert selection to morph. In floor plan, I will select the element and offset just in this edge. Offset edge 30 centimeters. In 3D, you can check. Now that my entrance is done, let's make the concrete inclined and pointed form. Go to Roof Story, place the roof DWG reference. You can use the ArchiCad slab parameters. I'm gonna use polygonal geometry to draw. And rectangular geometry. In 3D, I'll make a height adjustment. So here you select two slabs, Ctrl D on vertical, Z-axis, and click on Node. In the floating palette appears strat height. Put here 8 centimeters down. I will select just one of the slabs, transform this element in morph, convert selection to morph, OK, offset edge, and take it up. I'll do the same for the next. Now, to do the vertical part, go to ground floor and make a wall of 30 centimeters thickness. Here on ground floor, I put ground floor as reference. Select wall, and here I choose a 30 centimeters thickness, not linked, and 80 centimeters height. Here I model the wall. Go into 3D. It's exactly the height of this inclined element. Do a copy using Ctrl-Shift-D. Drag a copy. And here, selecting the wall, I'll do a strat height until the top. You see this small difference here. So here I will click on Node, this morph element. I will select, click on Node, move Node. Here you can see the floating palette, move Node, black pencil, and here I need to use, clicking on this node, on the upper node, snap guide. Using the Z-axis. So we need to find here a point. The intersection point on vertical edge. Convert this element to morph. Here I'll move node onto the edge. Inside you see this face that isn't correct. I'll click on node again. But this time I choose this pencil icon, add polyline. I'll click in this bottom point. And now you see the two plans added on structure, and this concrete structure in the house front is done. Now it's time to create the steel slanting columns. Go into Settings Dialog here on Column 2. You can see that it's possible here in Segment. It's possible to get a circular profile, but this time I won't use it because my pillars are tubular steel profiles filled with concrete. So I need to create a custom profile to do what I want. I close, go to Options, Element Attributes, Profile Manager. Here, click New. I'll type steel column plus concrete, diameter 20 centimeters. Okay. Using 2D elements, select Arc and Circle tool, clicking on origin point, radius is going to be 10. I'll click, create another circle, radius 9. Using Fill tool, I'll choose Reinforced Concrete as fill pattern. Inside, press spacebar to use magic wand, click, and it fills. Fill tool again. I will choose now steel structure, magic wand, pressing spacebar. I'll click, but now we need to fix this one. I will select the fill, and keeping it selected, I'll choose Fill tool, press space bar again to use the magic wand, do a click, and it makes a hole. So now we have this steel structure fill and this concrete fill. Select the steel fill, and here at the right we have this tab component. I will define this element as finish, mark override surfaces. I will override with paint gloss white, show cut end lines. I'll put a black line 101, and it's very important to mark which type of element this profile shall be used. Here I'll keep this column, save, close the window, and go into ground floor. Keep the ground floor DWG reference. On settings dialog, I'll choose here the column 2, settings dialog. On segment, you can choose a complex profile. Here I'll select steel column plus concrete that we've created. Turn off override surfaces on model because you want to see the white paint we have chosen. In column, I'll change here to define a slanted column with 80 degrees. In my link to the first floor, I'll type an offset of -30, considering the slab thickness. So here you see total height as 2 meters and 93. I'll press OK. Click to insert. I'll drag this element, Ctrl D, to place it on the right position. I'll check on 3D. You can see it's all right. In floor plan, I can mirror a copy, Control Shift M. Selecting two elements, I will group the elements selecting them. In Arrange Elements bar, we have this option Group. And I will turn off Suspend Group. Now you can see this element being selected together. Control Shift D to drag a copy, using structure's axis as reference to click. So here we have another copy, Control Shift D. And here I will copy two, but we have a double height. So you can see on 3D, we have here two situations. We also have on stairs opening, a pillar of double height. So here on floor planning section, I will change to home and one story up, the representation on 2D. And I'll link height on settings dialog. I'll link to roof and put -20 because the roof's lead has 20 centimeters. Okay. And now you see these double height columns. Now to finish structure on first floor, I will invert the slanted columns, selecting the columns on ground floor. Control C to copy, go into first floor, Control V to paste. So you can see here on 3D, I will invert the slanting columns. So here I will click Ungroup, erase one, press Delete, and now I will rotate this column, Control E. In the middle of the reference line, I find a mark. Here is the first click, and the second click aligned with blue line. Then I can rotate 180 degrees. I can mirror a copy, Control Shift M. And here I can see on 3D to check the result. And I will group these elements. And now it's just to draw copies, pressing Control Shift D. And okay, this was our class about structures. Wait for you on next class. Bye bye. Hello, welcome to class 10 of the ArchiCad 23 online course. In this class, we're gonna model the wooden decks and swimming pools. Now we have the house structure completed. If you didn't the entire structure on last class, you can open the file Orlando House, class 10. Go into underground floor in our file. Place the reference underground. Here in the back part of the land, we have a grass surface to be planned, a flat surface, and we have a sloped grass surface here. In both cases, I could use Mesh tool But in flat surfaces, I can also use slab tool. So going to slab tool settings dialog, I'll make settings for grass, slab thickness, I'll put 10 centimeters, level -6, building material soil. In floor plan and section, cover fields, keeping foreground and changing cover fill pen to 137. In model, I can deactivate these two surfaces, and so they're gonna use soil from building material, and the top surface is gonna be grass green. Layer, I'll change to Arc for Garden. Okay, to start the modeling, I'm going to choose a polygonal geometry method, and I can model my garden flat area. To design the deck, enter on slab 2 again. I'll keep thickness as 10 centimeters and level -6. Building material this time is plywood. In cover fields, I'll place a fill that is plank floor. First pan 150 and background pen 130. It is a light gray. Turning on all surfaces in model, I'll put floorboards 3. I can keep the garden layer, Arc for Garden. Okay. Using rectangular method, draw the deck. Check on 3D. To position the grass a little bit below the wood deck, I will select this element. Control 9 is the shortcut to elevate. I'll put -4, and now it's good. Now we need to adjust the deck fills in floor plan. Turn off the reference, and you see that my wood deck fill has an undesirable break here on material. Select the slab, floor plan and section, cover fill orientation. We have the option Custom Distortion. An element indicating the origin point appear, clicking in this point. With the option Move Fill Handle, in my floating palette, I can move and set the origin point to the fill. The vertical line determines the fill scale. To keep real scale from plank floor fill, we need to set 1 meter. The other line defines the fill angle. So here I'll place at the corner, and now on 2D representation, the fill is almost correct. You see a little difference. In the end, the line is not exactly matching the edge. Then, to fix it, go to Options, Element Attributes, Fills. Here I select blank floor. The motif is here, spacing 15.20. I'll type exactly 10 centimeters. Okay. And now it's right. In 3D, we need to adjust surfaces because the image texture used on model is independent from 2D views. So go to Options, Element Attributes, Surfaces. Select Floorboards 3. In the Texture tab, we can add the image, for example, changing the angle for 90 degrees. You see it changing on 3D. Coming back to surfaces, I'll keep the angle 0. The total dimensions here determines the size of each wooden ruler. So the image is divided into 20 rulers. Considering 10 centimeters to each one, we have 200. Okay. Using the measure tool in 3D, you could check approximately 10 centimeters. Okay, now we're gonna do part of the pool. Go to ground floor and put ground floor as reference. Select Wall tool, enter on Settings dialog. It will be not linked. Level to home story is -2 and 30, as well as wall height, 2 meters and 30. Because the wall top will be on level 0, being the pool border, and as this wall is on level not being cut, I should change floor plan display to outlines only. Here on floor plan display, outlines only. Building material is reinforced concrete and 20 centimeters wall thickness. In model, I will turn off the padlock. By one side, I will keep concrete light. In the middle, stone marble black. And at the other side, tiles mosaic blue. I'll keep layer arc 4 structure. Okay. Well, here in my project, I have a round pool with a spa that is like a hot tub. Besides that, a wet bar. It makes a connection with the kitchen. We have a small kids pool and a pool lane that has a slope. So it begins with 1 meter and 50 of depth and ends 2 meters and 10 centimeters here. Choosing rectangular method to model, I'll start clicking here and finish using snap guide because we don't have this point. So I place the mouse, appears the snap guide, intersection point, and I do the click. You can check on 3D. So here it comes as a grouped element. I'll mark suspend groups to edit only this wall. It has a 15 centimeters thickness. So here I do the adjustment. And on 3D, this face here, we're gonna do a glass wall. Let me show the image. So here you see, In this pool border, there is a massive glass creating a nice effect, seeing the pool water. We have more images so you can understand our project. Going to 3D window, select the wall. In settings dialog, I'll put just 20 centimeters of height. And here I'll change surface materials. By one side is marble black, in the middle mosaic blue, here we have a problem to be resolved later. Now I'm gonna do the pool bottom, and as it is a sloped structure, I need to use roof tool. So going to floor plan, I'll click roof tool, enter in settings dialog, level is -2 and 30. I'll keep reinforced concrete, slope is just 4%, and model, only the top surface in mosaic blue, and concrete light to the other faces. Okay. Here I draw the line that is the reference of the bottom level. Click, the eye appear. Click on the side in which the roof goes up. So it's here. The pencil appear. Choose rectangular method and design the element. I'll press ESC to arrow selection and check on 3D. We have a sloped structure and it needs to be adjusted to 20 centimeters thickness. Okay, now it's right. And you can check the height using the measure tool. So here we have 1.50 meters. And here 2 meters and 10 centimeters. To do the glass wall closure, copy the wall with Ctrl-Shift-D. Select Strat, clicking on the reference line. We have Strat, and here I can adjust the element. In settings dialog, wall height 210, building material I change to glass, wall thickness 5 centimeters. In model, I'll put glass clear fast. Layer, I'll keep structure. Okay. And here I will drag 15 centimeters to inside. In floor plan, you can see that 2D representation is incorrect because the lower wall is connecting to side walls. To avoid the connection, I can make a millimetrically smaller dimension. So here I could put 319.9, and at the other side you can do the same thing. So now the representation is correct. Now I'm gonna do the pool water volume. I choose slab tool. In building material, I put water. In model, we have two types of water, but the better surface to do it is not here yet. So I will choose water wave just for a while. In cover fields, I'll put foreground with 140 pen. And finally, the water volume is going to be formed by slab thickness. So here it's going to be 205 and level -5 to water top. Okay. To design, I can even use magic wand to fill, space bar and click. The water needs to be brought to front. So I choose pressing the tab. I can alternate between elements. Here appears slab to me. I click and bring to front. Looking on 3D, you see the water surpassing the pool bottom because it has a sloped structure. So to fit water volume, I'll do solid element operations. Go to Design, Solid Element Operations, select the sloped plane and put as operator, get operator elements. The pool water, I'll put as target. And subtraction with downward extrusion. Because I want to cut the bottom part now, click Execute. And it's ready, the water is right now. To finish, I'll just change the surface material. Click in Options, Element Attributes, Surface. I can add a material clicking on New, New from Catalog, Linked Libraries, ArchiCad Library 23, and here I can search the landscape folder, water, and here we have water pool. OK. I'll click OK and selecting the slab, going to Settings dialog in Model. The new material is displayed in the list. Water pool. OK. You see the difference in 3D, and especially when you got to rendering. Well, in this class we learned how to work with gardens, decks, and pools. On next class I will bring a file with all these elements already modeled that we may focus on next lessons. Okay, wait for you on next class. Bye bye.